Lesson 4.5, the normal distribution. Our objective for this lesson is to be able to use the 68, 95, 99.7 rule to find the frequencies of data values in a normal distribution. First, let's define normal distribution. A normal distribution is a symmetric bell-shaped distribution with a single peak. We often call it a bell curve because of its shape. And it has a single peak, and because it's symmetric, that peak, right at that peak, you're going to find the mean, median, and mode all at the same place there because of the symmetry of the distribution. So it's symmetric, it has a single peak, and ends up with this bell shape curve. So the conditions for a normal distribution. First of all, most data values are clustered near the mean. That's going to give it that well-defined single peak right around the mean. Two, the distribution is symmetric around the mean, meaning that the data values are distributed evenly on both sides of the mean. So you don't have a long tail on one side and not the other. It's symmetric on both sides of this peak that represents the mean, median, and mode. And three, larger deviations from the mean become increasingly rare. So you get the little tail on both sides of the mean. As you get farther away from the mean, you're going to get it's going to be just very few values that are far away from the mean, and so it kind of tapers off on either side into these little tails on both sides of the mean. All right, so the 68, 95, 99.7 rule for a normal distribution. We're going to talk a lot about this rule, and we're going to use this to determine how to determine the frequencies of different values within a normal distribution. So the rule is that about 68% of data values fall within one standard deviation of the mean. That is between one standard deviation below the mean and one standard deviation above the mean. In that entire region, you're going to find 68% of the data values. And then about 95% of the data values fall within two standard deviations of the mean. So from two standard deviations below the mean to two standard deviations above the mean, in that region, you're going to find 95% of the data points. And then the same thing for three standard deviations of the mean. About 99.7% of the data values are going to fall within three standard deviations of the mean. So here we have a graphic representation of the normal distribution and the 68, 95, 99.7 rule. So you can see the red line is the bell curve or the normal distribution. And this blue line in the center represents the mean. And then each of these dotted blue lines represents one standard deviation. So what we can see here is that 68% of our values, our data values, are going to lie in the center here, within one standard deviation above and below the mean. 95% of values are going to lie within two standard deviations above and below the mean. And 99.7% of values are going to lie within three standard deviations of the mean. For our example, we're told that vending machines can be adjusted to reject coins above and below certain weights. The weights of legal US quarters are normally distributed with a mean of 5.67 grams and a standard deviation of 0.07 grams. If a vending machine is adjusted to reject quarters that weigh more than 5.81 grams and less than 5.53 grams, what percentage of legal quarters will be rejected by the machine? So here we're told that the that the mean for a quarter is 5.67 grams. And we're told that the standard deviation is 7/100ths of a gram. So one standard deviation above the mean would be 5.74 grams, and two standard deviations above the mean would be 5.81 grams. One standard deviation below the mean would be 5.60 grams, and two standard deviations below the mean would be 5.53 grams. We're told that the vending machine is going to reject quarters that are above 5.81 grams or below 5.53 grams. And we're asked what percentage of legal quarters are going to be rejected by this machine. And so you can see from our 68, 95, 99.7 rule that 95% of values are going to lie within two standard deviations of the mean. And we were told that it's going to reject anything below 5.53 and above 5.81. Notice that those values are two standard deviations away from our mean. So the question is asking us how many quarters are going to be rejected that are outside of two standard deviations from the mean. And we can see that if 95% are within two standard deviations of the mean, 5%, the remaining 5%, are going to be outside, are going to be in this region, these two regions out here in the tails. So the answer is 5% of our quarters are going to be legal quarters are going to be rejected by this machine because they lie outside of two standard deviations from the mean.